Welcome to the continuation of sections 7.2 and 7.3. Now remember that just a few things we have to make sure you know by now is that whenever we want to take the derivative of the natural log of u, it's 1 over u du by dx. Chain rule all the time. So the derivative of the natural log of x with respect to x is 1 over x. So the derivative with respect to x of the natural log of u would be 1 over u times the derivative of u. And of course for u being differentiable and greater than 0. Now if on the other hand you go the opposite direction, if you want an integral of du over u, see that's that part, okay, it's going to be the natural log of the absolute value of u plus a constant. Because remember, the argument of the natural log is always positive. Okay, a few things we have to remember as well would be the natural log of 1 is 0, because remember this is saying what did I raise e to get 1? It's e to the 0 equals 1. Naturally, the natural log of e is 1. The product rule is that if we take the natural log of a product, it's equal to the sum, the natural log of each factor. So it's the sum of the natural log of each factor. Now if you have a quotient, by quotient rule, if it's the natural log of b over x, it's the natural log of b minus the natural log of x. And if we have the natural log of x raised to a power, let's say the natural log of x squared, the natural log of x to any power right here, it's equal to r times the natural log of x. This is really just an extension of the product rule, because if you have r many factors of, x raised to the r, that means there are r factors of the natural log of x. There are r factors of x, so that means r of these many natural log of x's. Okay, so let's see, where did we leave off from the next from the class? Let's see where did we. Let's go ahead and open up a new slide and say we want to work on the problems that we left off. And let me check. All right, I think we were doing number 40. It's possible that we did 41. So let's say we do 43 or 42. So suppose we want to do 42. So number 42, we're looking at finding the integral of, it's a definite integral from 0 to pi over 3 of 4 times sine theta d theta all over 1 minus 4 cosine theta. Okay, so here right away you should be looking out for what's a du. So most likely that's a du right there. Well, let's see, find out first what our u is. So let u equal to 1 minus 4 times what? The cosine of theta. So what is du? So du would be 0, that's 0, minus 4 times the derivative of cosine is a minus sine theta d theta. And cleaning up everything here, we're going to have 4 sine theta d theta. And you see we have a match. There's your match right there. So that's your du. So let's go ahead and rewrite everything. So now it becomes the integral. Okay, and remember, whenever I've already done my substitution, I don't put the limits of integration because, this is in terms of u. But what we have so far is that's your du on top, and you have u at the bottom. So the integral of du over u is the natural log. Remember, that's a derivative of the natural log. So it's the natural log of u. And then let's go ahead and rewrite everything as the natural log. Notice I didn't put a plus a constant because we're looking at a definite integral. So the natural log of 1 minus 4 cosine theta, evaluated from where? From 0 to pi over 3. So here is just trig application. So we have the natural log of 1 minus 4 times, okay, what is the cosine of pi over 3? Cosine of pi over 3 is 1/2, and then minus the natural log of 1 minus 4 times, what's the cosine of 0? The cosine of 0 is 1. So far what we have would be the natural log of, that's going to be 1 minus 2, which is -1, minus the natural log of 1 minus 4 is the natural, and then in absolute value, that's the natural log of 1, minus the natural log of 3, and we know that what's the natural log of 1? That's 0. So your final answer would be negative natural log of 3. Okay, let's turn to number 40. Let's turn to number 43. Okay, so if you have your notes, number 43, we've got the integral from 1 to 2 of 2 natural log of x dx over x dx. Okay. Well, you might think, oh, the one at the bottom should be u. Not necessarily, because look, what would happen if you let u be this? Then you're going to get du would just be dx, and we don't know how to rewrite that in terms of u. So maybe we'd have to look at a different strategy. So what I'm going to do here is to rewrite a few things. Okay, so suppose we write it this way. I'll pull out the constant 2. So let's put out the constant 2. Okay, and then I am going to regroup, put these together. So, and then the natural log. So let me go ahead and say it's the integral, okay, of the natural log of x. And then I'm going to multiply this. So I'm going to write this as 1 over x dx. Right there. Okay. So now, if you see, we have a du here, and that means I could write, let natural log of x be equal to u, because, okay, let's do that. So let u equal to the natural log of x. Almost always when you have an integral of this form and you see the natural log of x, that becomes your u because it can't be a du. So du would now be 1 over x dx. Okay, do you notice why I did that? So that you can recognize that what we've got so far is 2 times the integral of, alright, what's your natural log? That's your u, so you just put u. And what's du? 1 over x. So this is your u, and that whole thing is your du. So I'm just going to write it right up here. And that's just the power rule, so it's 2 u squared over 2. So that becomes u squared, and then rewrite it back into what u was. So u was a natural log of x and squared. Now I can plug in the limits of integration from where? From 1 up to 2. So that's equal to the natural log of 2 whole thing squared minus the natural log of 1 whole thing squared. But what did we say what the natural log of 1 is again? That's 0. So this whole thing is 0. So that's your final answer, the natural log of 2 whole thing squared. Okay? Now mind you, please make sure that the natural log of 2 squared is not the same as the natural log of 2 whole thing squared. Okay? Because this means it's a natural log of 4. But this is the natural log of 2, then you square it. Okay, so they don't mean the same thing. So make sure you're aware of that. Don't get that mixed up. Okay, let's turn to another problem. I see here number 45. Let's do number 45. Okay, in number 45, it's very similar, but what you have is it's the integral from 2. Let me erase that. From 2 up to 4. Okay, and then again, let me write it. It's going to be dx over x natural log of x whole thing squared. Okay, and again, let me rewrite it this way. So it's going to be the integral from 2 to 4 of, I'm going to write it this way, 1 over the natural log of x, whole thing squared, multiplied by dx over x. Do you see how I just rewrote everything? That way you can recognize that this should be our u, the natural log of x, because you have a du right there. So let's go ahead and say let u be the natural log of x. We can't be this whole thing be u. It has to be just the natural log of x because that has to match with the du. So what's our du? Du is 1 over x dx. There we have a match right there. So that is our match. So now let's rewrite everything. So it becomes the integral. Okay. So now what we've got is the integral of 1 over, remember our u is natural log of x, so this becomes 1 over u squared du. And that's again application of the power rule. It's going to be u to the minus 2 du, which is equal to u to the minus 1 over minus 1. And then write everything now. That's going to be negative 1 over, what is our u? Natural log of x, evaluated from 2 to 4. Okay. And I'll let you take care of the substitution here for, all the rest of it, so that we can keep going. So as you can see, whenever you see a natural log of x and an x in the denominator, right away it gives you a hint that you let u be the natural log of x.